Typically, pedestrian crosswalks are located at intersections in front of stopping traffic, as indicated here by the red arrows. The alternative crossing, we call in this presentation displaced crossing, shifts crosswalks to mid-block crossings. This could be along any approach of the intersection or all approaches. The displaced crossing would yield benefits to pedestrians. Specifically, at multi-lane intersections, the typical way of serving pedestrians poses additional discomfort as the pedestrian would have to cross several lanes to clear the intersection. This also puts the pedestrian in close proximity to turning traffic, more specifically, right turns on red, and unprotected left turns. However, at the displaced crossing, we would eliminate conflicts with turning traffic, and we would allow for a shorter length of the crosswalk. The displaced crossing would also yield benefits to vehicles. At a hypothetical intersection having 4 phases consisting of east-west left turns, east-west through movement, north-south left turns, and north-south through movement, this intersection will have about 104 seconds of effective green time. Distributing this green time based on the traffic volumes of each of those phases, we would get about 15 seconds for the east-west lefts, 49 for the east-west throughs, 9 seconds for the north-south lefts, and 31 seconds for the north-south throughs. If there exists a pedestrian wanting to cross from the south side to the north side, and the distance to be crossed is around 120 feet, which is a typical distance at multi-lane arterials. This distance would require the phase that's concurrently being served with the pedestrian phase, here color-coded in blue, to be extended from 31 seconds to 44 seconds, and hence adding delay to all other approaches. However, at displaced crossing, having a shorter crosswalk length, we could potentially bring that back to its original 31 seconds and save delay on the other phases. Optimally, the displacement distance would locate the crossing right before turning lanes. This would help in eliminating crossing excessive distance. 2 geometric configurations could be utilized at the displaced crossing. First option is a coordinated displaced pedestrian hybrid beacon, and the second option is a coordinated 2-stage displaced pedestrian hybrid beacon. The first option will still have the pedestrian served concurrently with the adjacent intersection through movement, here seen in box D. A simulation of the first configuration can be seen here of Ronald Reagan and US 40 in Plainfield, Indiana. Here exists a pedestrian wanting to cross from the north side to the south side of the intersection. This pedestrian is being served right now concurrently with the adjacent intersection through movement. The second option will have pedestrians served in 2 stages. This will allow for pedestrians to be served along with 3 of the adjacent intersection 4 phases, here seen in boxes A, C, and D. A simulation of the 2-stage pedestrian hybrid beacon can be seen here of Ronald Reagan and US 40 in Plainfield, Indiana. Here again exists a pedestrian wanting to cross from the north side to the south side. The first stage of the crossing is being served concurrently with the adjacent intersection north-south left turns. The pedestrian will then wait at the refuge island between opposing lane, and then the second stage is being served with the adjacent intersection north-south through movement. All in all, the displaced crossing means improved pedestrian safety and improved vehicle service. For pedestrians, they will have less conflicts now with turning vehicles and will potentially have a refuge island, allowing them to wait between opposing lanes. For vehicles, reduced interactions with pedestrians would mean reduced delay and being less disruptive to the vehicle progression along the corridor. This also allows for an additional alternative in the designer's toolkit. For example, along US 52 in West Lafayette, Indiana. Between Winchell Boulevard and Cumberland Avenue, there exists a future development under construction to the west and a trail to the east, shown here in red. In a hypothetical scenario, if we shift the pedestrian crossings from both Winchell Boulevard and Cumberland Avenue to a displaced crossing in the center, we could potentially reroute the trail through that displaced crosswalk and possibly could allow for early left turns at that location, which would lead to reducing the number of left turners at both Cumberland Avenue and Winchell Boulevard, and hence enhance timings at both intersections. Based on our simulation results, we find four main factors playing a role in terms of the extent of benefits gained from the displaced crossing. Factor number one is the displacement distance, where that distance can't be too close to the intersection as it may increase delay to vehicles, but it also cannot be too far from the intersection as it could divert pedestrians. The second factor was the volume of turning vehicles, where it was found that the higher that volume is, the greater the vehicle's level of service benefits are. Third factor was signal timing, where fewer lanes to be crossed would have a shorter pedestrian clearance interval and would result in less vehicles delay. Intersection geometrics was the last factor, where surrounding driveways, the ability to provide a refuge island, and the possibility to reduce lanes crossed with the displacement were also playing a role in the extent of benefits gained.